So in this video we will study about the chemical properties of carbon compounds. Okay, so in our textbook we are already studying about four types of reactions. Okay, the first one is combustion, second one oxidation, third one addition, and fourth one substitution. So we will study about these four type of reactions. So chemical properties means these reactions. Okay, so always when we are saying about chemical properties, understand we are saying about the reactions. Okay, so first let us study the first one. So these are carbon compounds we are studying. So combustion reaction. So our first question is, what is combustion reaction? So I'll write the definition. So read this. So the a reaction or burning of carbon compounds in the presence of oxygen, okay, to form carbon dioxide and water, okay, along with heat and light. These type of reaction is called combustion reactions. Okay, for example, imagine we are burning a paper. Okay, so when we burn a paper, so heat and light is produced obviously, and also there is release of carbon dioxide and water vapor. So we can write some examples. So first one I am writing is C plus O2. It's very easy. So what will be the product? Yeah, if there is no hydrogen, only CO2 will be formed. Okay, and we are also studying heat and light, so you should write heat plus light. Okay, so we got one reaction. Now let us write another reaction. This also you will be able to write CH4 plus O2. What will be the products? So what we have studied, it will form carbon dioxide and water. Okay, so write CO2 plus H2O plus heat and light. Heat plus light. You just need to balance it. So try balancing it. When you balance it, you will get 2 here and 2 here. Okay, because there is 4 hydrogen here. Okay, 4 hydrogen, so we will write 2 here. So then total oxygen on the right hand side will become 4, so we write 2 here. Okay, so we can write number of other examples also. If we take CH3CH2OH, this is an alcohol. Okay, so if we are reacting it with oxygen, what will be the product? This is also a carbon compound, so your product will be CO2 plus H2O. Okay, so don't forget this. So these are the products of combustion reaction. Okay, whenever it burns with oxygen. So basically the thing what happens is, imagine if the compound is like this. Whenever it reacts with oxygen, see, all these bonds will break. Okay, and everything will be attached by this oxygen. So CO2 and each hydrogen will attack to form H2O. That is what happens there. Okay, so just try to understand that as well. Okay, then mostly these carbon compounds are used as fuels. Okay, so there can be a question, why carbon compounds are used as fuel? Okay, so this question can be asked, why carbon compounds are used as fuel? The reason is because they give a lot of heat when it is burnt. Okay, that is the answer. It gives, carbon compounds give a lot of heat. So you take the example of petrol, diesel, kerosene, etc. They release a lot of heat when it is burnt. Okay, like coal also, but coal is comparatively less, coal and firewood. So petrol, diesel, kerosene, they all produce a lot of heat. That is why also when they start to burn, they will just continue to burn. Okay, because when like a paper, for imagine if this is a paper, so imagine you have lit fire here. Okay, so it will spread like this because the heat energy released is enough for the remaining part to burn. Okay, so that is why, for example, if we are taking coal also, coal, firewood, etc., it will just continue to burn like this. That is also an advantage of these carbon compounds. Okay, so don't forget they release sort of heat when it is burned. That is why it is used as fuel. Okay, now another important thing that you need to keep in your mind is that there is two type of compounds, okay, that we have already studied: saturated compounds and unsaturated compounds. unsaturated compounds. Unsaturated means having double bonds or triple bonds. Saturated means only single bonds. When these both are burned, okay, when we burn both these things, we will get different color of flames. So this saturated compounds, when it is burned, it will give blue color flame. Okay, so don't forget that. So saturated compounds, because they mostly undergo complete oxidation, that is why. Okay, but the thing about unsaturated compounds is that when it is burned, it will give mostly yellow color flame. Okay, yellow color flame. Okay, so when we burn like paper, for example, we'll get an yellow flame, right? Also, when we burn plastics, probably we will get an yellow color flame. Okay, because these are all unsaturated compounds. But if you look at your kitchen, there LPG. Okay, LPG is mostly having butane. Okay, LPG is mostly having butane. So when it is undergoing burning, it will give blue color flame. Okay, so also remember, blue color flame implies complete combustion. Okay, complete combustion. And yellow color flame means partial combustion. Okay, so just keep in mind these 2 points also. Okay, so now that is all about combustion that we need to know. Next we can look at the oxidation. So our second type of reaction, oxidation reactions. So these are reactions in which oxygen, okay, and oxygen gets added to a compound. Okay, so here we are only studying, so in our textbook we are only studying the example of CH3CH2OH, which is this compound. Yeah, ethanol. Okay, so we are only studying about the oxidation of ethanol. Okay, so we can add oxygen to this. So what will happen is they will become CH3COOH. So what is this? This is ethanoic acid. Okay, so when ethanol undergo oxidation, it will become ethanoic acid. So who will help to undergo this reaction? So we have two things. Okay, so don't forget these two things. One is alkaline KMNO4. Okay, so this is, the name is potassium permanganate. Okay, potassium permanganate. Potassium permanganate. Okay, KMNO4, or you can have acidified K2Cr2O7. Okay, so the name of this is potassium dichromate. Okay, so this is a purple color thing. Okay, this KMNO4, this will be a purple color solution, and K2Cr2 will be an orange color. Okay, that is the difference. These are two different things, but when ethanol is treated in the presence of these two things, okay, what we need to add is we need to give some heat also. You just heat this mixture. Okay, so ethanol, when it's heated along with alkaline KMNO4 or acidified K2Cr2O7, you will get ethanoic acid. Okay, so if you closely observe here, what you can see is, so here in this reaction an oxygen is added. Okay, an oxygen is added along with simultaneous removal of hydrogen. Okay, hydrogen means H2. So you can see here, so one H2O is lost. Okay, in place of that an oxygen is being added. Okay, that is why we say so. So these two things, KMNO4, okay, this one KMNO4 and this K2Cr2O7, both of them are called oxidizing agents. Okay, oxidizing agents. So a question can be asked, What are oxidizing agents? So substances that are capable of adding oxygen to other substance are called oxidizing agents. Okay, so I'll write the definition, you can copy that. Okay, so this is the definition. So also remember one more thing, this alcohol, okay, alcohol, we are taken ethanol. Ethanol is an alcohol. Alcohol will convert into ethanoic acid is a carboxylic acid. Okay, carboxylic acid. So only this under, there's a condition, there should be complete combustion. Complete combustion means there should be enough oxygen, enough what we can say, enough conditions. Okay, appropriate condition, temperature, everything should be there. If alcohol is undergoing partial combustion, it will become its respective aldehyde. Okay, so in the above situation, it's ethanol, right? So imagine if example, if ethanol was undergoing partial combustion, PC means partial combustion, what would have been formed? Ethanol means it will be CH3, okay, CH3 CH2 OH. So its respective aldehyde will be formed. That means aldehyde having two carbons. What is that? You can predict it. You can pause this video and predict it. It is ethanol. Okay, C double bond O H CH3. Okay, ethanol. So this will be formed if it is partial combustion. So keep in mind this as well. So that is all about oxidation reaction. You only have to study this one type of reaction. Okay, ethanol changing to ethanoic acid. Now we can study about the third type of reaction. Okay, third type of reaction is addition reactions. Okay, addition reactions. So I will write the definition of addition reactions. So read this, a reaction in which a reagent gets added to a compound, okay, or reacted without the removal of any small molecules. Okay, so we can study this using an example. Okay, so let us take a compound like this. Okay, this R means alkyl group. Okay, so mostly these addition reactions will be undergoing by alkenes. Okay, double bonded compound and alkynes. So we only need to study for one example for alkenes. Okay, so imagine there is a double bond. So the reaction that we are studying is addition of hydrogen to this compound. Okay, so addition of hydrogen. So for that, what we require? We require catalyst. Okay, like nickel catalyst. Okay, nickel catalyst or palladium catalyst also we can use. Okay, palladium catalyst. Palladium catalyst. A catalyst means some molecules which increase the speed of the reaction. So when this condition is there along with some temperature like 200 degrees Celsius, what happens is, see here we have written, right, a reagent gets added to a compound. Okay, so here hydrogen, okay, is getting added here. Okay, so this double bond breaks. Okay, and you can see, I will rewrite that using this white color. So there is C, okay, and then there is this double bond breaks. Okay, then there will be these two R, but the thing is our hydrogen will also get attached. Okay, so we will get this product like this. So that is the advantage of addition reactions. So imagine if it was a compound like this. So what is the name of this compound? Yeah, it is ethene. So if ethene is undergoing the same reaction, okay, so there is this catalyst, hydrogen 200 degree Celsius. Okay, nickel Ni, okay, nickel or palladium catalyst. Okay, so what will happen? This double bond breaks and there will be hydrogen, hydrogen, hydrogen. So it will become ethane. Okay, that is the use. So basically here we are only studying one example, and that example is hydrogenation reactions. Okay, these reactions are also called hydrogenation reactions because hydrogen is getting added to the compound. Okay, so this is only we need to study. So an industrial use of this hydrogenation is people hydrogenate vegetable oils. Okay, vegetable oils are hydrogenated. So you might have seen or used vanaspati. Okay, that is like a solid type of thing. Okay, it is similar to butter. So basically if you hydrogenate vegetable oil, we will get different substitutes. Okay, like uh, a similar substitute for butter we will get, substitute for butter. Okay, so like vanaspati, so that is one use. Okay, hydrogenation of vegetable oil. So this is all we need to study in addition reaction. So just study this one reaction. Okay, that's enough. Now coming on to our very last reaction, that is substitution reaction. Okay, so I have given here the definition. So substitution reactions means you need to understand here a reagent, okay, gets added to a compound with simultaneous removal of an atom or a group of atom. So we will take the example of methane. Okay, so mostly these substitution reactions are undergone by alkanes. Okay, you also need to understand alkanes are mostly very inert, they are not very reactive, but in the presence of sunlight. Okay, so one second. So in the presence of sunlight, and if there is chlorine, substitution reactions can happen for these alkanes. So you know what will happen, this one chlorine atom will replace this hydrogen. Okay, there will be remaining three hydrogens, but one chlorine atom will replace, and that chlorine atom will come with the other hydrogen to form HCl. So similar to this, a substitution happens. So this thing Cl is getting substituted, so hydrogen is getting removed. Okay, that is why this definition is so. So this reaction will continue like this. Okay, now it is CH4 plus Cl2. So there is sunlight. So what we got? CH3Cl plus HCl. Now the second thing is this CH3Cl can also undergo substitution. Sunlight. So what will happen? One more hydrogen will be removed from this. So we will get CH2Cl2 plus HCl. So it will continue. Okay, it will continue, and again it will form like CH2Cl2 will react with Cl2 to form CHCl3 plus HCl. Okay, in the presence of sunlight. So that means substitution is happening, continuously happening. So this will be the last substitution because there is only one hydrogen remaining. So in the presence of sunlight, this hydrogen will be removed to form CCl4 plus HCl. Okay, now the reaction stops. So basically this is like a chain reaction. Okay, so you can write any one reaction, that is totally fine. So just understand substitution reaction. So one thing gets substituted in the place of another thing. Okay, so these are the four type of reaction we have studied. Combustion, okay, reaction with oxygen to form CO2 plus water, then oxidation, that is addition of oxygen, then addition, we only studied addition of hydrogen. Okay, it is also called hydrogenation reaction. Then substitution, alkane plus Cl2 in the presence of sunlight. Okay, so these four reactions, keep in mind, understand these reactions. Okay, thank you.